Let's look at transversals. So a transversal is the line that intersects, really, it doesn't have to be parallel lines. I shouldn't say that. It just intersects two lines that can be parallel. Within a transversal, there are 5 different types of angles we're looking at. We're looking at vertical angles, adjacent angles, alternate interior angles, alternate exterior angles, and corresponding angles. The important thing to note is that a transversal does not have to be through parallel lines, unlike what I had originally written there. So this right here would be the transversal that is cutting through 2 lines. But these 2 lines obviously aren't parallel. So we still will have these different measures of alternate interior angles, alternate exterior angles, vertical angles, but they're not going to have the same conditions as if they were parallel. So if we did have an example like this, where line M here is our transversal, lines L and line M are parallel. And I could kind of note that on here and say that these are parallel to each other. When a transversal cuts through parallel lines, well, it creates some congruent angles within here that I'm going to talk about right now. And they're only congruent if it is parallel. So vertical angles are 2 angles that are opposite angles and share a common vertex formed by the intersection of 2 lines. Their angles are congruent. So there's lots of different examples of vertical angles here, but if we look at this example, okay, these 1 and 3 are examples of vertical angles. They're kind of opposite each other there. Or I could look down here and I've got 7 and 5, or 4 and 2, and 8 and 6. Those are all examples of vertical angles. So let's write a few down here. We've got, let's say, angle 4 and angle 2, or angle 8 and angle 6. Those are both examples of vertical angles. Adjacent angles. If you think of the word adjacent, it means next to. So adjacent angles are 2 angles that share a common vertex. So they share a common vertex and a common side. So they share a vertex and a side. Well, let's think about what that means here. We have a vertex and a vertex. Well, right here, 1 and 2 share a vertex and a side. So that's one of our adjacent angles, angle 1 and angle 2. Well, let's continue around clockwise here. We've got angle 2 right here. We have a vertex and a side connecting 2 and 3. They are right next to each other. So angle 2 and angle 3 are adjacent angles. Let's keep going around clockwise here. We've got angle 3. We've got a vertex and a side connecting 3 to 4. So angle 3 and angle 4 are adjacent angles. Continuing to go around. We've got angle 4 here that has a vertex and a side connecting it with angle 1. So 4 and 1 are adjacent angles. Now let's look on the lower part here. We've got our angle here and a side connecting 8 and 5. Those 2 are next to each other. They are adjacent angles. So angle 8 and angle 5. Then we've got our vertex here and this side connecting 5 and 6. So angle 5 and angle 6, I think I might have not printed enough there, but let's keep going. We've got angle 6, we've got a vertex and a side connecting 6 to 7. And we actually have one more. We've got angle 7 with a vertex and a side connecting 7 to 8. So angle 7 and angle 8. Alternate interior angles are angles that are on opposite sides of the transversal, so that's key. Opposite sides of the transversal, and are inside the parallel lines, interior, inside. This is when the lines are parallel, their angles are congruent. So obviously, again, we can have transversals that cut through lines that aren't parallel. But if you have a transversal that's cutting through parallel lines, alternate interior angles are congruent to each other. So let's look here. We've got inside, we've got our parallel lines here. So we're talking about the angles that are on the inside. We're talking about these 4 angles here. So which ones are on alternating sides of the transversal? Well, if this is our transversal, we've got one angle right here that's on the opposite side of the 5. So they're both on the inside and on opposite sides. So angle 4 and angle 5 are alternate interior angles. And the other ones that we would see right here, we've got angle 3 on the opposite side of angle 8. So those are the other pair of alternate interior angles. So angle 3 and angle 8. Well, let's look at this other definition then. We've got alternate exterior angles, which if you guessed it is the same idea, but instead of on the inside, it's on the outside. So they're opposite sides on the outside. And again, if the lines are parallel, then those measures are going to be congruent to each other. So we're looking at those on the outside. We're looking at these two that are on the outside of our parallel lines. So here's our transversal. We've got 1 is on the left side, 6 is on the right side. So those are a pair of alternate interior angles, angle 1 and angle 6. Then we've got angle 2 is on the right side, angle 7 is on the left side. And if you look at them, it looks like they are the same measure. This is an obtuse angle, these are acute angles. So our last one here was angle 2 and angle 7. And then the last type of angle that we're going to look at is corresponding angles. They are angles that are in the same position at each intersection where a transversal crosses 2 other lines. And again, when the lines are parallel, their angles are congruent. So basically what we're looking at here is we've got our 2 parallel lines, and they both have 4 angles on it. You've got one on the top left, one on the top right, one on the bottom right, one on the bottom left. On the bottom here we have top left, top right, bottom left. Well, we're saying, okay, the 1 is on the top left and the 8 is on the top left. So those are corresponding angles, angle 1 and angle 8. Then we've got 2 is on the top right and 5 is on the top right. So angle 2 and angle 5 are corresponding angles. Then we've got 3 is on the bottom right, 6 is on the bottom right, so angle 3 and angle 6 are corresponding angles. And then we've got angle 4 is bottom left, angle 7 is bottom left, so 4 and 7 are corresponding angles.